You know, you use it every single second you're online, but you probably never even think about it. It's your computer's address. So today, we're going to break down what that actually means and why it is so important. I mean, have you ever really wondered? You hit send on a message, you search for a video. How does that information navigate the entire massive global internet just to land on your screen and not your neighbor's? Well, it's not magic, I promise. It's actually a surprisingly simple address system. And this is the core idea right here. Every single device that's connected to the internet, we're talking your phone, your laptop, even your smart fridge, has a unique address called an IP, or Internet Protocol Address. It's just like how the post office needs your street address to deliver a package, the internet needs an IP address to deliver your data. Simple as that.
All right, so let's start at the very beginning with the original postal service that basically built the internet as we know it.
The first system was called IPv4. That's Internet Protocol version 4. And it was, well, foundational. An IP4 address looks just like this, a string of 4 numbers, each separated by a dot. It's super straightforward, and you know what? For a very long time, it was all we needed. The formula is incredibly simple. It's literally just 4 numbers separated by a dot, and each of those numbers can be anything from 0 all the way up to 255. That's the whole structure. Pretty easy, right? But that beautifully simple system had a tiny little flaw. A flaw that the internet's pioneers didn't really see coming. It was just too small. So when you do all the math, this system gives you just under 4.3 billion unique addresses. Now, back in the 70s and 80s, that seemed like an almost infinite amount. I mean, who could possibly imagine a world with more than 4 billion computers? Well, we did. That 4.3 billion number might seem huge, but think about it. Right now, you might have a phone, a laptop, a tablet, maybe a smartwatch. That's 4 devices for just one person. Multiply that by billions of people, and yeah, you see the problem. We officially ran out of space. The internet's original address book is completely full. So what do you do when your address book is full? You invent a brand new system with a lot more room. It was time for Plan B. So on the left, you've got the familiar IPv4 address we've been talking about, and on the right, that's its successor, IPv6. You can see the difference right away. It's way longer, and it uses letters in addition to numbers. This is a whole different animal. Those letters are part of what's called a hexadecimal system, which is just a fancy way of packing a ton more information into the address. So how many new addresses does IPv6 give us? That many. That number is 340 undecillion. And just to put that into perspective for you, it's enough addresses to assign one to every single atom on the surface of the Earth and still have plenty left over. So yeah, we are not running out of IPv6 addresses. Okay, so we have a nearly infinite number of addresses. Awesome. But how does a packet of data find its way through that massive haystack to find your specific phone? The answer is a really beautiful concept: hierarchy. See, the whole system works because it's not just one giant flat list of addresses. It's structured in layers, just like a lot of other systems we use every single day. And a perfect example of this is a US phone number. Think about it. When you dial a number, the phone system doesn't look at all 10 digits at once. First, it looks at the country code to send the call to the right country. Then the area code to get it to the right city or region. Then the local exchange. And finally, the last 4 digits make one specific phone ring. It's like a funnel, right? It gets more and more specific with each step. And guess what? IP addresses work the exact same way. Here's the key thing to remember. An IP address isn't just one number. It's made of at least 2 parts. The first part identifies the big network, kind of like the area code for your internet company. And the second part, that identifies your specific computer on that network. And we can take this whole hierarchy idea even further. Let's zoom in from a huge internet provider to a place a lot of you probably know pretty well: a university campus. A university might get a giant block of addresses, like everything that starts with 141.213. But to stay organized, they create smaller networks inside of that, called subnets. So the next number, 127, might be assigned to, say, the medicine department. And the very last number, 13, points to a specific lab computer inside that department. You see the funnel again? University to department to desk. Now, this all makes perfect sense to us humans looking at these nice, neat decimal numbers. But computers, well, they don't think like we do. They think in ones and zeros. So how does the machine itself actually read this address?
Okay, so let's stick with our university computer address. This is what we see. 4 simple numbers separated by dots. It's easy for us to read and understand.
But the computer, it sees this, just one long, unbroken, 32-digit string of ones and zeros. To the machine, there are no dots, there are no separate numbers. It's just one big binary code. And this is where the system gets really, really clever. Because it's all one long string, the people running the network can decide exactly where they want to slice it. They can say, okay, the first 16 bits, that's our entire university. The next 2 bits, that'll be the department. And the final 14 bits will be for the individual computers. They can slice and dice that binary string however they need to. So what does that actually mean in the real world? Well, by using just 2 of those bits for the department, the university can create 4 subnets, maybe one for medicine, one for engineering, arts, and admin. And by dedicating 14 bits for the computers, each of those departments can have over 16,000 unique IP addresses. It is an incredibly flexible and super efficient way to organize a huge network. Which brings us all the way back to that gigantic, unbelievable number for IPv6. This amazing system of addresses and hierarchy is what lets the internet function and grow. But it also leaves us with one final thought. We now have the ability to connect trillions upon trillions of devices. So just imagine for a second, a world where we actually use them all. What does that world even look like?